All right, folks. So in today's video, we're going to take a look at this Ailunce HD2. It's a new radio from Retevis. It is an analog and a DMR radio, and it can be configured to be a tri-band radio in ITU Region 2, which happens to be North America. It will operate on 2 meters, 220 and 440, so 3 bands, making it a tri-bander. In today's video, we hook it up to some test equipment like this TinySA Ultra. And we do that to test the spectral purity, or the harmonic emissions that come out of this radio. And we'll talk about that in a second. In addition to connecting it to the TinySA, I connected it to a Siglent Spectrum Analizer. And you'll see the results of both of these devices. I wanted to say that I was contacted by Retevis or Ailunce, and they asked if I would do a video review of this product, and of course I said yes. So they sent this to me free of charge in exchange for this video review. If you're the type of person who gets triggered by things like that, it's best you go watch some cat videos. Okay, so let's just take a quick second to talk about spurious emissions and the rules that come from the FCC, and that means that an amateur radio operator is responsible for the purity of their equipment, regardless of where they got it. And it says the mean power of any spurious emission from a station transmitter or external power amplifier transmitted in a frequency between 30 and 225 megahertz must be 60 dB below the mean power of the fundamental. And so that means that for this particular radio, we are concerned about the 2 meter band, 144, and the 1.25 meter band, 220. Now it says for a transmitter having a mean power of 25 watts or less, which would be this particular radio, the mean power of any spurious emission supplied to the antenna transmission line must not exceed 25 microwatts and must be at least 40 dB below the mean power of the fundamental emission, but need not be reduced below the power of 10 microwatts. So at the bottom, I did a little bit of math for you, and I showed you what 25 microwatts is in dBm. It's negative 16.02, and 10 microwatts is negative 20 dBm. All right, so what we have here is the scan that I did on my Siglent Spectrum Analizer, and a couple of different things. We have a marker table down here at the bottom that shows each one of the data points at the various frequencies. And so we did this test at around 145 megahertz. It says 144 because of the number of data points that it collects. It's not a big deal. And what you can see is that we were right around 36 dBm at our fundamental frequency, which is just under 5 watts. That's fine. I had about a 3-foot coaxial transmission line, and we probably got a little bit of attenuation, so I'm quite confident that it puts out 5 watts on high power like it should. What you can see here is that we have markers 2, 3, and 4 at harmonics of our fundamental. And in the case of number 1, it's 40 dB below, which is okay. And then marker number 2 is 32 dB below, which is not okay. Marker number 4 is 50 dB below, which is okay. But all three of these are also above that negative 16.02 dBm threshold, meaning that each one of these has failed the second criteria of the test, and the radio is not compliant with FCC regulations. So in order to test this again, what I did is I did the test on my TinySA, and the results are extremely similar, indicating that both equipments work the same way. Both pieces of equipment are working the same way. Here you can see the fundamental is at 37.5, so it's slightly higher. Now in this case, I did not use that same transmission line, and I think we're okay. But the delta between the markers is similar, and it's similar enough that it does not pass the test for marker number 3 for both criteria, and then for markers number 2 and 4, they are above the negative 16.02 dBm threshold, meaning that all three of these markers, again, failed the test for the second part of the test. So what I also did is I did the same test on the 1.25 meter or 220 band. And when I read that, our fundamental is over here at marker number 1, and it was a little bit higher than 5 watts of output. That is typical. Sometimes you'll see the further higher you go in frequency, the stronger the emission. But when you take a look at marker number 2 and marker number 3, marker number 2 is only 27.8 dB below the fundamental. It's supposed to be 40, so that would fail that criteria. Marker number 3 is 53 dB below, so it passes that criteria. But again, both 2 and 3 are above the threshold of negative 16.02, which would mean that this fails the spectral purity regulations from the FCC on these two harmonic emissions. That's really going to wrap up this video. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. Thanks for watching, everybody. Much appreciated.